Let's try this again with coffee. All right. Sorry I lost you there for that last one. Okay, so yeah, see? Cheers. Makes all the difference. As I was saying, we have this triangle, and we have this segment PD that goes straight through the triangle. And we're given that 1 and 2 are a linear pair. Excellent. That sounds very useful. We're also given that so we're given 2 sets of information. One, that they're a linear pair, and this one, that 1 equals E and E equals 2. Okay, so let's use them. First step of a proof. Always the information that you have. So let's start with this one. That 1 and 2 are a linear pair. Okay, now we are eventually, in the last proof, we were trying to get to angle measures. We are not trying to get to angle measures here. We're trying to get to 2 line segments being perpendicular. So if you kind of think backwards from there, like, oh, okay, for something to be perpendicular, according to the definition of perpendicular, they have to form a right angle. The 2 line segments have to form a right angle, or 2 lines have to form a right angle. So, right angle. If we can get to there being a right angle, then we can get to this where they're perpendicular. Okay, so how do we get to a right angle? Let's find out. So let's see, that one was given. Okay, 1 and 2 are a linear pair. Okay. Shall we progress with that? I don't know. I'm not seeing anything that's going to get us directly to the other one. We want something that leads us from a linear pair to right angles. And your brain should be going ding, 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 ding. Like, I know something about a linear pair that leads to right angles. And it's when you've got a linear pair, but they're equal. So let's see. 1 and 2 is a linear pair. Is there a way for me to show that they're equal? Look at this. Yes, this is good information. So let's move directly to this next set of information, which is that 1 equals E and E equals 2. It's the other given. And now I think we've got it. Okay, so from here, we would love to be able to show that 1 and 2 are equal. And conveniently, 1 equals E and E equals 2. And this is where you'll find the transitive property really, really useful. Because if that equals that, but that equals that, then that means you can just jump from one to the first one to the last one. And that is how you would use the transitive property. Okay, so now we have it. We've got a linear pair where the angles are equal, and we have a theorem. Oh, Sydney, you'd be able to tell me which one it is. 8, maybe? 10? Let me take a look. Let's see. Aha! It was 8. I was right, Sydney. You proud? Here we go. If the 2 angles in a linear pair are equal, then each is a right angle. There you go. Woohoo! I'm going to go ahead and write it out, though, so I can remember it. So if 2 angles in a linear pair are equal, then each is a right angle. So that means that they are right angles. I didn't even name that one. 1 and 2 are right angles. Because if 2 angles in a linear pair are equal, then each is a right angle. Excellent. So now we know that they're right angles. So if 1 and 2 are both right angles, then that means that we have met the definition for the criteria of perpendicular lines. We have SA and PD have to be perpendicular. SA is perpendicular to PD. And the reason for that is the definition of perpendicular lines, which says that if two lines form a right angle, then they are perpendicular. Okay, so that's it. Another 5-step. I think both of those wound up being 5 steps. Ooh, I forgot. Ray's favorite part. Dun, da, da, da. Quo erat demonstratum, and you're done. I am going to make one more video now about the algebra review in this section because I thought maybe some people could use some help with that. Okay? See you around, suckers.